This video is on multiplying radicals, and you should follow along and copy down the work onto your notes just like we would do in class. So this first one is kind of like a formula. If you have the square root of a times the square root of b, you can multiply the numbers underneath the radical. So this problem would simplify to the square root of ab. Now that's much different than if you were adding them. If it was root a plus root b, you wouldn't be able to combine them. But multiplying is friendlier. There's a little bit more you can do with them. So next example, make sure you're keeping up. Root 5 times root 2 will become the square root of 10. 5 times 2. The next one is root 5 times root 10x. And I just need to multiply the numbers underneath the radical. Those are sometimes referred to as the radicand. So 5 times 10x, the 5 times the 10 is 50, and the x just tags along. Okay, those were the most basic examples. And then here, you'll notice that after you multiply the 3 times the 6 to get an 18 underneath, then you need to simplify the square root of 18 because there's a square factor in 18. I didn't have to do that on 10 because the only factors of 10 are 5 and 2, and neither of those are square. But if I do that for the 18, 18 can be rewritten as 9 times 2, and then the 9 can come out, and when it comes out it will be a 3, and the square root of 2 is still under there. Alright, so the next one here, we get the square root of 9 times the square root of 9. That's what the squared means. And the square root of 9 times the square root of 9, you have two choices here. You could rewrite this as the square root of 81, which will simplify just to 9. That's one way. Or you could have just figured out that the square root of 9 is just 3, because 9 is a square number, so the square root of 9 is just 3, and then if you square that, 3 squared gets you back to 9. So two options of doing number 5, either one is perfectly fine. Alright, just pausing for just a minute so you can get caught up if you're behind. Okay, so square root of 7 squared. Now I can't simplify the square root of 7, so I'll have to think of it as root 7 times root 7. And the square root of 7 times the square root of 7 is the square root of 49. And the square root of 49 is just 7. So there you go. There's 1 through 6. Okay, they get a little trickier from here. So be patient, know that they're kind of hard, and pay attention, ask questions of whichever teacher's in the room. Hopefully someone will be able to help you a little. So here is kind of a formula again. You see how there's a number on the outside and a number on the inside. So you can take this x and the y will multiply each other on the outside, and the a and the b multiply each other on the inside. Let me explain that a different way too. This is x times root a, and this is y times root b, and all of these things are just multiplying each other. So you could reorder the multiplying and just say, oh well, that's x times y times root a times root b, and x times y is just xy, and you already learned from up above that root a times root b can just be root AB. Okay, so trying that with this one, the 5 and the 3 will multiply because they're on the outside, and the root 2 and the root 7 will multiply as root 14. So multiply the outsides, multiply the insides. Let's try this one. So 2 root 7 times 2 root 7, the 2's will multiply, the root 7's will multiply, and then stop and look to see if this can be simplified some more. The square root of 49 is 7. And 4 times 7 is 28. All right. Notice when I took the square root of 49 that I just wrote 7, not the square root of 7. That's a common error sometimes. And if you go back over here to think about this 14, I didn't need to simplify 14 because there are no square factors inside of 14. All right, next, square root of 3 times 4 root 2. There's a 1 in front of this square root of 3. Might help you figure out what's going on. So the 1 and the 4 multiply each other, and the root 3 times root 2 becomes 3 times 2 under here, or just 6. So 4 root 6 is the answer. All right, next one. So root 2 times root 3, I'm going to use the distributive property to multiply this out. Because this is a binomial with two terms, that's how I know I need the distributive property. It's kind of like if you had 2 times x plus 4, you know with that structure you have to use the distributive property. This is the same idea. So root 2 times 3 can be a little confusing because the 2 is under the square root, but the 3 is not under the square root. So this just becomes 3, go back to blue, times the square root of 2. There's a 1 out here. You can think of that 1 multiplying the 3, and then the 3 doesn't have a square root part. You could think of it as the square root of 1 right there next to it. So this root 2 times root 1 is 2, and 1 times 3 is 3. And then here, 1 root 2 times 8 root 6. The 1 times the 8 is 8. And root 2 times root 6 is root 12. All right, and now look at that answer to see if either can be simplified, and you'll notice that the root 12 can be simplified. So the 12 can be rewritten as 4 times 3. And then the 4 can come out. And when you take the 4 out, it changes to a 2. And you get the square root of 3. So it's 3 square root of 2 plus 16 square root of 3. Alright, so now this bottom row here definitely gets more complicated because you have a binomial times a binomial, and you have to use the distributive property twice here. Just like you do if you have to do a problem like x plus 4 times x minus 7. We have to do x times x minus 7 and 4 times x minus 7. We need to do that same kind of thinking on this problem. So 2 root 3, write kind of small here so that you don't run out of space, is root 3 minus 7 plus 4 times root 3 minus 7. So 2 root 3 times root 3 will be 2 square root of 9. 2 root 3 times 7. The 2 and the 7, neither of those are underneath the radical, so those multiply. And the root 3 just tags along. And then 4 times root 3 is just like 4 times x. One's under the radical, one's not, so you can't multiply the 4 and the 3, so you just say 4 times root 3 is 4 root 3, and then the last number is 28. Alright, then you need to look at each term and see if they can simplify. Since the square root of 9 is just 3, get that, and minus 14 root 3 plus 4 root 3 is a negative 10 root 3. And then 2 times 3 is 6. And 6 minus 28 is negative 22 minus 10 root 3. And either order on that would be fine. Negative 10 root 3 minus 22 or negative 22 minus 10 root 3. Alright, number 13. Root 5 minus 3 times root 5 plus, root 5 minus 3. And we're going to multiply out the same way. You have to use the distributive property twice. Notice the minus here compared to this problem was 2 root 7 without a plus or a minus in between. This is root 5 minus 3 and it has the minus here, making this a binomial. So you have to use the distributive property twice. Root 5 times root 5 minus 3 minus 3 times root 5 minus 3. So root 5 times root 5 is root 25. 3 times root 5, or root 5 times 3, is just minus 3 root 5. 3 times root 5 is 3 root 5. And negative 3 times negative 3 is positive 9. So root 25 is 5. And those combine to make negative 6 root 5 plus 9. 5 plus 9 is 14 minus 6 root 5. Alright, moving on. Same idea. Root 3 times root 3 minus 4 plus 4 times root 3 minus 4. I took the root 3 times both of these and the plus 4 times both of these. So root 3 times root 3 is root 9. 4 times root 3 just becomes 4 root 3 plus 4 root 3 minus 16. 4 times 4. So notice these, a negative 4 root 3 and a positive 4 root 3. Those cancel out. And root 9 is 3 minus 16, because this just equals 0. And 3 minus 16 is negative 13. So that's kind of neat that this whole big complicated expression with the square roots in it simplifies all the way down to just an integer. Okay, you try the next set. Good luck.